Okay, welcome to Algebra 2, Semester 1, Unit 4, Section 4.10. This is the last section of this unit, so when you finish this, do the bookwork and then be prepared for a study guide and a test. Okay. So these are word problems, and we're going to be looking at how to solve them. What I really like about the quadratic word problems is that they're not too difficult to solve once you see what's happening. And we always think of the graph and then figure out how we can find the numbers to represent that. So if a football is kicked into the air and its path is described as a quadratic function, y equals negative parentheses x minus 10 parentheses closed squared plus 30, where y is the height of the football in feet after x seconds, what is the maximum height of the football? So if we think about this parabola, it's going like this, and we're asking what's the highest point. On a graph, what is that called? If you said maximum, you are exactly right. And what would this line right down the middle be? That would be your axis of symmetry. Now let's see how they gave us the formula. They gave it in HK format, so plus or minus a x minus h plus k. Remember with HK format, this is your vertex, your HK. Remember, this is also a vertex. In fact, if you had said vertex instead of maximum, that would also be correct. So all we need to do is find our vertex. Well, that would be 10, 30, and that means that the maximum height in feet for that football would be 30 feet. Okay. The next one. A rocket is launched off of a platform with the initial velocity of 19.6 meters per second. The path of the rocket can be modeled with this equation. Looks like we have standard form this time, where h is the height of the rocket and t is the time in seconds. After how many seconds will the rocket hit the ground? So we're looking for the seconds. The h is the height. Let's just draw this path of this rocket. So it might go something like that. What we're looking for is the number of seconds. Well, we're given the seconds and the t right there. One thing that we need to make sure and fill in is our height. Otherwise, we'd have two variables and we can't solve without having just the one variable. So what is the height here and here for that rocket? If you say the height is 0, you are absolutely correct, because when that rocket hits the ground or before it launches, it's 0. So we have 0 equals negative 4.9 t squared plus 19.6 t plus 58.8. Now, the first thing that I want to get rid of is this negative off the front end. We don't ever factor with that. And I have a feeling we're going to have to find the t value. So it's going to involve some kind of factoring. So the first thing I do is I divide everything in the equation by negative 4.9. If that looks kind of ugly to you, feel free to grab a little calculator or grab your phone and divide it, but it comes out real nice. You can do it by hand. It ends up being t squared plus 6t plus 12. Now, I made a little mistake here because the negative and the negative would make a positive. But here, a negative and a positive should make a negative, shouldn't it? And a negative and a positive there should make a negative. Okay. So now we've got it set equal to 0. We can factor. And I'm sorry, that should be a 4. Boy, oh boy. Negative 4t. Okay. And we ask ourselves what two numbers multiply to be 12, negative 12, and add to be negative 4. So I can put my t in here. I know negative 12 would be a negative and a positive. And if you think of the factors 6 and 2, you are correct. The larger one farther from 0, would have the same sign as the middle number there. So now we set each of these equal to 0 to solve for our second. So t plus 2 equals 0 when t equals negative 2, and t minus 6 equals 0 when t equals positive 6. Well, we can't have a negative time, so that one's an extraneous solution. It solves the problem, but it doesn't solve the equation for our circumstances. So we have t equals 6. That means that the rocket, after how many seconds will the rocket hit the ground? The rocket will hit the ground in 6 seconds. Okay, so I was thinking one thing. Oh, I know what it was. Back up to the last problem. Since it's a word problem given, we should answer it with a word, with a sentence. Sorry. So it says, what is the maximum height of the football? We should write the maximum height of the football is 30 feet. Okay, anytime you're given a word problem, please answer it with a complete sentence. Okay, anytime you're solving these word problems, always ask yourself, are you trying to find the x-intercepts or the vertex, and draw a picture. You notice I didn't even talk about x and y intercepts, we just drew the picture and talked about what we were looking for there. Okay. Next page. A football is kicked into the air, and it is modeled by the equation negative 16 parentheses x minus 5 squared plus 21, where x is the horizontal distance in feet and f of x is the height. What is the maximum height of the football? This is exactly like the one we just did. Please turn off the video and you solve it and then turn it back on. Okay, so maximum height of the football is 21 feet. We have a storage building shown in this picture to the right. X is the horizontal distance, so right along here, this from there to there is your x value. And your height is your y value. And we're asked, what is the width of the building? Well, sounds to me like we need to find what our intercepts are here, and then find their difference to see what the width is. So then it asks, what is the maximum height? So we're going to have to find all of these. We have it in standard form. So we have to ask ourselves, what is the name of this line that goes down through the middle of the parabola? If you said axis of symmetry, you are absolutely correct. So now we find our axis of symmetry for that equation. And the equation again is y equals negative x squared plus 24x minus 44. Here's our a value, our b value, and our c value. And our axis of symmetry formula is -1/2 times b over a. b is 24, a is 1, -1, so 24 over -1, -1/2 times 24 over -1 would be a positive 24 over 2, or positive 12. So that means that this place on the graph is 12. We plug that in order to get the height. -12 squared plus 24 times 12 minus 44. -12, should put it that way, 12 squared is 144, then the negative out front. 12 times 24 is, let me find this, I'm just trying to look at my notes here. I did not do it that way in my notes, but I think that it'll still work. So we have a negative, it should work. So we have a -144, 24 times 12 would be 8, 48, 0, 4, 288. We'll see if we come out with the same answer. 288, and then minus 44. So we have -144 and a positive 288. That would end up being 144 minus 44 equals 100. That's looking a little bit steep. Let's go ahead and solve for the x, and then we'll come back and plug some things into that equation, make sure that it's right. So we're looking for our x-intercepts, and the best thing that we could do is convert this standard form into intercept form. So in doing that, we have negative x squared plus 24x minus 44 equals y. And now we want to get rid of that -1 there off the front end of that. So first thing that would do, the y, obviously finding our x-intercepts, the y is going to be 0 because we're at ground level. So now divide everything by -1. We would end up with x squared minus 24x, negative and a negative, plus 144 equals 0. Okay. So now to put it into, I'm sorry, I don't know where I came up with 144 other than our other problem. It's 44. Negative 44 divided by -1 is a positive 44. How can we factor that? Factors of positive 44 that add to be -24. If I list all my factors, I have 1 and 44. Those add to be 45. 2 and 22, oh, those two add to be 24. So we have x minus 2 and x minus 22. So x equals 2, and that equals 0, and x equals 22, and that equals 0. So we have 2 and 22 here. It asks what is the width of the building. I would write the width of the building is 20 feet. That's because 22 minus 2 would be 20 feet. Now let's double check that the height is really 100 feet. So that seems a little bit tall for that shape of a building, unless they've just purposely drawn it completely out of scale. So the midpoint here between 2 and 22, well, it's 20 apart, so if we add 10, would be at 12. Let's plug in 12 for our x value. 12 minus 2 equals 10. And 12 minus 22 would equal negative 10. So we have 100 feet. We do end up with that 100. So I guess the height would be 100 feet. Seems rather odd. Down at the bottom, explain why there can only be 0, 1, or 2 solutions in a quadratic. Remember, your solutions are your x-intercepts. So we have the option of a parabola intersecting twice on the x-axis. We have the option of a parabola intersecting once on the x-axis. And we have a parabola not intercepting the x-axis. So that's why. Okay, last page of these notes. Can you graph functions in intercept and standard form using the vertex and solutions? You need to come into class and be prepared to do that. We'll be doing that on our whiteboards, and I'll be quizzing you. Once you do it correctly on the whiteboard, then I'll have you copy it in here, and I will be checking your notes to make sure that you've done one with me right here. Compare graphing equations completely when they're in intercept versus vertex form. What are the benefits of each? Well, let's look at this. Vertex form, I'd like to go further than that. Let's look at all three. Vertex is plus or minus a times x minus h plus k, and it's squared there. Intercept form y equals plus or minus a times x minus p times x minus q. And standard form is the ax squared plus bx plus c, plus or minus. Okay, all of these have the y equal to them when you're graphing, or f of x equal. So the advantage here is your vertex is highly visible, and you can quickly locate the rest of the graph off of transformations, which we've done a lot of. But if you're looking for the vertex, like the height of something, things that way, then it's real easy to plug that one in. On this one, just like the name says, the intercepts with the x-axis are most readily available, and you can see that easily. Okay, so intercepts is the main reason to graph that if you're looking for the x-intercepts. And with standard form, I think what makes it nice is you've got the y-intercept located easily. And oftentimes this is the format that you get problems in, and you have to convert it to one of the others. Okay, come to class ready to finish that unit off, do a study guide, and then we'll have the test. Thank you very much.